Hi everyone, my name is Thomas Kim. Today is December 5, 2019. This is 41st episode about linear algebra and the threading building blocks. In this episode, we will implement algorithm for system of linear equation using back substitution. In our previous episode, episode 40, Gaussian Elimination algorithm, Sequential Recursion, please double-click this link. In episode 40, we used Gaussian Elimination algorithm to make upper triangular matrix. By upper triangular matrix, I mean something like this. So this is called diagonal matrix A11, A22, A33. These are diagonal elements. Other than diagonal elements, all elements are 0, 0, 0, 0, 0. We can say if I is not equal to j implies aij is 0. This matrix is called diagonal matrix. Now let's think about lower triangular matrix. This is A11, this is A12, this is A13. This element is 2, 3. So if I is less than j implies aij is 0, then we call such matrix lower triangular matrix. In this case, this is 2, 1, this is 3, 1, this is 3, 2 elements. If I is greater than 0 implies aij is 0, then it is upper triangular matrix. This is system of linear equation. From this system of linear equations, we formed augmented matrix. From this augmented matrix, we cancelled out first elements of each row other than pivot row. We cancelled out all elements to 0. Then we formed this new matrix. This element now becomes new pivot. Using this pivot, we cancelled out the first element of each row other than pivot row. We formed this matrix. So finally, we obtained upper triangular matrix. So we formed this upper triangular matrix using Gaussian elimination. Using Gaussian elimination in our episode 40. In my future episode, we will also implement low triangular matrix. Since we are C and C++ programmers, instead of this fancy-looking mathematical notation, we will use more C++ friendly notation like this. 2x0 plus x1 minus x2 equal 8. Minus 3x0 minus x1 plus 2x2 equals minus 11. Minus 2x0 plus x1 plus 2x2 equals minus 3. From this notation, we form augmented matrix 2, 1, minus 1, minus 3, minus 1, 2, minus 2, 1, 2, x0, x1, x2 equals 8, minus 11, minus 3, we formed this new augmented matrix. From this matrix, we use indices starting with 0. So this is 0, 0, 0, 1, 0, 2. This is 1, 0, 1, 1, 1, 2. This is 2, 0, 2, 1, 2, 2. And this we denote V0, V1, V2. In symbolical notation, we say A00, A01, A02, A10, A11, A12, A20, A21, A22, X0, X1, X2 equals V0, V1, V2. We denote this matrix of this form. This form of matrix is easier to deal with in C++ programming. Now we form a matrix like this: A00, A01, A02, A03, A10, A11, A12, A13, A20, A21, A22, A23, A30, A31, A32, A33. So this is a square matrix, 4 by 4 square matrix. And we have a column vector x0, x1, x2, x3. This is column vector equals v0, v1, v2, v3. This matrix and this matrix are called column vector. In our previous episode 40, in this video, by using Gaussian elimination algorithm, we transformed this matrix into upper triangular matrix. So all elements below diagonal element are 0. I will delete them. All elements below diagonal elements are 0. Instead, this element is 0, 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 this element is 0. This is upper triangular matrix. If we perform matrix multiplication, first row, first column, then we have A00, X0 plus A01, X1 plus A02, X2 plus A03, X3 equals V0. Since this term is 0, if we multiply second row with this vector again, then we have A11, X1 plus A12, X2 plus A13, X3 equals V1. In the same manner, A22, X2 plus A23, X3 equals V2. A33, X3 equals V3. We want to solve this system of linear equation starting with x3, then x0 in reverse order. So this is back substitution. We start with x3. If we solve this last equation for x, then it becomes x3 equals v3 minus 0 over A33. If we solve this equation for x2, then x2 becomes v2 minus A23 x3 over A22. If we solve this equation for x1, x1 equals b1 minus a12 x2 plus a13 x3 over a11. If we solve this equation for x0, it becomes x0 equals b0 minus a01 x1 plus a02 x2 plus a03 x3 over a00. Since this matrix is 4 by 4, row count is 4. This is I, so xi starts with x3. It means x row count minus 1. This is start index. Xi ends with x0. So xi ranges row count minus 1, minus 1. Starting indices is included and the indices minus 1 is not included. This is half open interval. That means we have to use signed integral type for indices I. In this equation, indices of x is I. So this is I, this is I, this indices is I, this indices is I. Also, these two indices are I. xi equals bi minus ai2 x2 plus ai3 x3 over aii. In this case, I is 1, so it is greater than 1. Okay, this is the starting indices. We will denote it by j. J is greater than I by 1. This is row count minus 1 and row count minus 1. So we can denote this xi equals bi minus sigma j. J start with I plus 1, I plus 1, and with row count minus 1, row count minus 1, and this is summation a I j times x j over a I. So this is our equation. In this equation, the range of I is row count minus 1, minus 1. The range of j start with I plus 1, row count. Following C and C++ convention, the start indices is included. The end indices is not included. The start indices is included. The end indices is not included. This is half-open interval. In summary, if we examine this equation carefully, indices of I include negative number minus 1, so we have to use signed integral type for I and j. Second, this is division by diagonal element. So these diagonal elements should not be 0. Diagonal elements aii should not be 0. Also, we can recycle these variables for xi. So we will use bi. bi equals bi minus summation ai j times bj over ai I. This is our algorithm. I will post this script in the description section below this video. If you double click this link, you can get this file from my website. In my next episode, I will implement our analysis in this episode into C++ program. Please subscribe to my YouTube channel. Thank you for watching.